All right, in this video, we're going to learn about physical properties related to the strengths of materials and then apply this information to solve some common engineering problems. The first one that we want to learn about is axial stress. Axial stress is the stress in a solid member. Axial stress, so we have axial stress. Is normally represented with the Greek letter sigma, which looks like that. Axial stress is defined as a force acting on a perpendicular cross-sectional area. Okay, we have another one called shear stress. Shear stress is represented by the Greek letter tau, which looks like that. It is defined as the force parallel to the cross-sectional area of a member divided by the cross-sectional area. Okay? So when a body is subjected to an axial force, the body undergoes a deformation. Total deformation is... So total deformation is represented by the Greek letter delta. Looks something like, not like that, something like this. We also have normal strain. So normal strain. Normal strain is represented by the Greek letter epsilon, which looks like this. Normal strain is defined as the deformation per unit length. We can also represent epsilon with a mathematical equation. We have epsilon, or normal strain, is equal to our total deformation, which looks like this, divided by length. Okay, so our original length. So sigma is our axial stress, and epsilon is our axial strain, and E is our modulus of elasticity. Okay. Modulus of elasticity. Our modulus of elasticity is sometimes referred to as Young's modulus also. Those are the same thing. Okay. So if we just look at a few ways that we can use some of these symbols as formulas. So if we look at formulas here, we've got the definition of normal stress, which is this guy is equal to our force divided by area. Okay. And then if we need, so this is normal stress. Okay. And then if we need normal strain, we have epsilon equal to so that gives us normal strain, like that. And then the relationship between stress and strain is that our stress stress is equal to strain multiplied by our modulus of elasticity. Okay, and then if we do some substitution and move some stuff along, we can find that the deformation of a material, or delta, is equal to the force times the length divided by the area multiplied by the modulus of elasticity. Okay, so those are just some of the main equations that we need to know in order to solve some stress and strain problems. Okay, so I want to look at a quick example. The first example is going to be a force of 150 pounds pushes on a round plate with an area of 30 inches squared. Okay, so how much stress does that plate apply to the ground? Okay, so step one is going to be identifying our knowns and unknowns. So if we look at what do we know? So knowns, here we know that F is equal to 150 pounds. We know that area is equal to 30 inches squared. And then our unknown, so unknown here is our stress. Okay, so we don't know what our stress is equal to. Okay, so step two here is going to be for us to draw a picture. Okay, so we've got a round plate and we've got a force going down on that plate, and then that plate is pushing on the ground. Okay, like that. All right, so step three is for us to write out any of the equations that we're going to need to solve this. So the equation that we're going to use here is that stress is equal to F divided by A. Okay, step four is to substitute and solve. We know that F is 150 pounds, and we know that A is 30 inches squared. Okay, so if we divide those out, we get a stress of 50 pounds per inches squared. Okay, and then step five is to convert any units that we need. In this case, we've got pounds per inches squared, or 50 psi, so that is in a good unit that we can use. Okay, so I hope this video was helpful for you guys to kind of understand just some of the different symbols and kind of how we can use them to solve different engineering problems.